and you should have a copy of this in the things I gave you on that last day. Um, so we have this chapter 21 investigative task that we're going to look at. This is going to kind of tie together a lot of different things from chapters 19 and 20 and 21. So this gives you a little bit of a background of the problem. You could read that later. In question one, well, you probably should pause the video and read it. During the 90s, about 63% of high school graduates enrolled in college. The pollsters hope to estimate the percentage of this year's seniors planning to attend college with a margin of error no greater than 4%. What size sample would suffice if they want to have 90% confidence in the estimate? Now, what I should have done was not even have this other stuff, because we don't even need to look at this to answer question one. We are dealing with, we want to make an estimate. They're talking about a confidence interval. So remember, that is the statistic plus or minus the critical value times the standard error of the statistic. So when we do that, our statistic that we would use, so we're going to use this one. So we're going to have, actually, no, we're not. We're not even going to use that because we don't need it. I didn't say that. Well, I did, and you could prove it. But okay, so the margin of error is this part right here. We don't want this for the margin of error. So what we're going to do is to get the margin of error, we need the critical value, which for a 90% confidence, looking on your yellow sheet, you would see that's 1.645 times the square root of, and then if you look back to see what the standard error of the statistic is, and you actually have that on your paper, it is the square root of, now it's p hat, but we don't know p hat because we're trying to determine the sample size. This is where we can use a known value that they give us. Remember, if they hadn't given us that, we would use 0.5, but I'm going to use 0.63, and then 1 minus p hat would be 0.37, and then we don't know the sample size. This is the margin of error, and we want that to be no greater than 0.04. So you're going to need to solve for n to figure that out. The reason I wanted to walk through that part of it with you is because we had that on a quiz, and I know some of you had some trouble determining the sample size. So you would need to be able to do that. Okay, so then now the pollsters randomly select, actually I think I might have this on the next one. The pollsters randomly select 5 cities in upstate New York and then randomly select 1 high school in each city. The guidance office at each of the chosen schools is instructed to ask 100 randomly selected seniors. So we have 5 different cities. So that means we have a total of 500 students. And what their current plans are, and to report the results back to the pollsters. The data collected from the schools are summarized in the table. So if you were to add these up, you do get 500. So this is 500 total students in our sample. So that's n equals 500. So you're not using the n that you found in the previous problem. This is now the sample. This is what they decided to do in the sample that they took. So then you are going to determine a 90% confidence interval. So you'll have to make sure you build that correctly for the percentage of seniors planning to go to college this year. So 289 out of 500. So there's your p hat value. And then explain carefully, make sure you explain what the interval means in the correct notation. Question 3, during the 90s, about 4.5% of high school seniors enlisted in the military. Do these data suggest that the percentage who enlist is different than this year? Test an appropriate hypotheses and state your conclusion. So your null hypothesis is going to be, nope, it's the same. So your null hypothesis is going to be that P is still 0.045. Your alternative, notice it says, is it different? So you can't look at the P hat value and say, well, it's smaller, so I'll say less than, or it's bigger, so I'll say greater than. The question just says different, so you have to, it's going to be a two-sided test. So you'll do the test, make sure you check conditions, and you go through and you do all the parts you need to do, and then you state your conclusion. Next question. A few of the seniors did not respond to the guidance queries, and others said they were undecided. Some of these people might eventually decide to enlist in the military. Suppose that half of this small group also enlist. So the undecided, that's like saying 11 more people decide to enlist. So now you're saying that 37 enlist. would that cause you to change your conclusion in question 3? So basically you're redoing question 3, but now you have 37 out of 500 in list, and now you have to decide, does that make a difference? Notice they don't give you an alpha level, so you're not told a particular thing. So I would use 0.05, if the p-value is less than 0.05. Question 5, explain in this context what a type 1 error and what a type 2 error would be. So remember, in general, what a type 1 error means is, okay, so a type 1 error again was the null hypothesis is true, but we say that it's not. So we end up rejecting the null hypothesis even though it was true. So you have to put it in the context of the problem you just did. Then for a type 2 error, remember what that means is that means that the null hypothesis is false. The alternative is true, but we failed to detect it. Okay, so the alternative is true, but we fail to detect it, but you got to put it into the context of the problem. So hopefully this gives you a little bit of an overview of what you need to do. So this is your assignment. Send me a message, or you can send me on Reminder, whatever, if you have any more clarifying questions, or you can post a question on Classroom.